or it is a metallic substrate or something like that. How do you measure? What is the surface? Right? That's where the tactile sensors come into picture. The developed piezoelectric sensors are used to measure the different surfaces like wood, textile, or metal. Right? That approach is called as tactile sensing measurement. So as you can see, the surface with zero point 0.4 millimeter roughness, which is giving a different frequency response, and zero point 0.6 millimeter is giving different frequency response, and zero point 0.8 millimeter is giving different frequency response. The way we did this experiment, these different, as I said, like zero point 0.4, zero point 0.8, and zero point 0.6 have been manufactured something called as things we call like this is here, and then this is our tactile sensor, which is a flexible piezoelectric sensor we measure, and then we slide it between using our XYZ stage, right? So, which is kind of giving a good temporal and spectral variation of the signal when the sensor is scanned over the pattern surfaces of zero point 0.6 to zero point 0.8 to zero point 0.4, right? So, you can also look for more information in publications in electronics. Okay, so another application. Now you understood how we can use wearables in machines. Now we also wearables in the humans, right? So one of the important application, you need to measure how the movement, like hand movement, is happening, or how person is walking in an industry movement. Similarly, these sensors are zero powered sensors, as you can see a word called self powered, right? Because the charges are already trapped in the sensor, so you don't need any external battery. You just put the sensor and you move them, and you're able to record the movement of the sensors. And then you can able to understand whether it's moving up or down depending on the response of the sensor. Similarly, the heart rate of the human can also be when he is working continuously in an industry with a different stress level and different temperature, humidity, you can continuously monitor the heart rate. It means this is giving a clear uh, kind of an proof that the sensor is able to measure very very tiny forces which is generating from our blood weight, right? Like, and also the gait measurement which I already showed, right? How our foot pressure distribution, how people are walking in an industry. Okay, so these are some of the examples. Maybe now I will stop here, and then we will end over to the next person. Maruti will introduce the next person. Thank you so much for the opportunity.
Yeah, thank you, Professor Vinay, for the wonderful talk on like how sensors are used in a smart factories. How basically like we can use the sensor technologies in this human robot collaboration. So now my other friend Manjunath, who is also an alumnus of Indian Institute of Science and is a leading expert in A and ML applications, we'll talk more about like once we get the data from sensors, how we can use that data to like train and make an inference based on that data, and how we can interact with robots based on that inference. Yeah, I land over to Manjana.
Hey, hi everyone. Not sure if my screen is shared. Can you guys see me?
Can you see slides?
No, it's not shared.
Okay, just a second.
Yeah. Okay. Hi everyone. Myself Manjunath. Uh, I did my masters in IIC and currently work for Goldman Sachs. And I lead a small team in Goldman to um, uh, you know which basically works. Our team basically uses AI to on the finances. I'll use this slide and the concepts here to relate with the previous the presentation that we saw where we talked about sensors, right? So coming to artificial intelligence or machine learning, right? The goal is to learn something from the data that we have already seen, right? The one we apply at my corporate level is, or the company level is for finance, but the same algorithms can be applied to data that is collected from sensors, right? Before that, we'll touch upon some basics, right? Artificial intelligence. I know most of you already know these things, but I'm just to, for the continuity and the for just for a remind, I'm going through these topics, right? So the basic artificial intelligence is the simulation of human intelligence in machines and programmed to think like humans, right? Because now if you go back and compare the data that we already the discussion that we previously had, right? So we are talking about the data that is collected from sensors, right? And probably if you don't have machines, then there is one person who is sitting and going through these census data, trying to come up with an inference saying that, okay, the data that is collected says some person is in stress. Or if it is from a machine, it says, okay, machine is going to some state where we are not able to, or it will basically stop working. Or if this is from a lift data, then we will know, okay, lift has done so many trips in one day. Or there is a bulb and we are collecting data from those bulb, then we'll say, okay, it may end, it may soon die, based on the data that is collected from sensors, right? So the all of these are the data that is collected from sensors. Today, if you go to any factories, machines, or even a simple corporate offices, there are thousands of such sensors and data is being collected from those, right? The artificial intelligence or the machine learning that we talk about today, uh, basically tries to, this concept we apply on this data and try to do some inference, right? and and why we need to use machines and cannot uh, rely on humans is because, just because of the scale. As I mentioned earlier, there could be 10,000 of such 10,000 such data which is collected, and it's collected at every 3 seconds or 5 seconds, right? And it is impossible for a human to go analyze that data and come to a conclusion, right? And that's why you use machines, right? Now now when we talk about the whole artificial intelligence, machine learning, right? uh, we usually see two types of learning. For example, if there is a sensor which is sending a data, and if the data is usually below, say, one, right? Let's say it's sending a signal that there is something issue with the machine, right? And then we can basically write a simple rule saying that if the voltage received from a sensor or a output received from a sensor is smaller than one, and that's why we know that it's going to stop working, or it has already stopped working, right? So those are kind of a weak rule based or a pattern based artificial intelligence. Or if you go today to chat gpt or large language models, right, which basically understands your question and try to answer your question. I hope everybody has used chat gpt, right? Those are kind of strong artificial intelligence because there are so many layers of network which is present, and there are so many values that machine has already learned and from the data and is trying to provide an answer. So these are the two different um types of artificial intelligence, we can say. And when it comes to sensors also, if it is a very small amount of sensors which are sending data, and then probably a rule based or a pattern based algorithms could be sufficient. But if you, when you look at the industry where there are tens of thousands of such sensors, and they're all interconnected, output from one derives the second one, and probably output of second says something else, we need to combine all of them and come to a final conclusion, right? So there, the simple rule based, we cannot sit and write a rule for everything, right? So then you need a machine who can understand all of this based on the previous data, right? I think we covered this in the previous slide, right? uh, and there are machine learning algorithms like, say, a random forest or a decision trees, right? What these are kind of a rule based, or then I mean, decision tree could be seen as a rule based, where you basically understand different features. For example, there is a data coming from a sensor, and it has 10 different values being sent, right? Say a power, a voltage, and on so many other things. You can write a rule saying that, okay, if the voltage level is better, so more than this, or some index heat is so better more than this, then it's going to happen. Case A is going to happen, or there are other value ranges. Based on that, you are going to go to a state two, or output is B, right? So you can write multiple rules, and there are so many such rule-based machine learning algorithms. Okay, learning versus designing, right? So this is very important part of any machine learning, uh, where you basically go and design an algorithm that basically gives you an inference. For example, if I plot all the values from uh, a sensor or any other machine learning data, right? Any other data, right? If I plot it on XY coordinates, and I need to write an algorithm that basically puts a boundary saying that anything on the left of this is class A, anything on the right is class B, right? How do I design that algorithm from which I'm able to write a boundary, right? That's basically an algorithm that I'm designing, right? Learning is basically using the data, and I basically I'll plot a, a a boundary which is probably wrong. Then I go and see, okay, I have made a mistake. This boundary is not correct, and I I count the error, saying that okay, you know what, data was something else. The boundaries total error is say 5, so I need to move this boundary towards my left, right? Based on the data which is already seen, we kind of draw such. I mean, we shift our boundaries and finally find the best boundary which suits the data. So, which is learning, right? This is some nomenclature we usually use, like artificial intelligence. Machine learning is a subpart of artificial intelligence. Deep learning is again a more one more study which is also, and everything else, everything, all of these deep learning, machine learning, everything is called an artificial intelligence. And if you're using the neural network and multiple layers of such neural networks, usually called deep learning, right? And the outer boundary, the second circle that you see dotted one, is more related to data, where how do you collect from sensors or from text based data or image data, right? How do you process it? All of that is kind of a data science. um, I'll skip few slides. I'll go to um, one important slide, and probably I'll the machine learn. Yeah, I mean, this is one such example I was talking about. XY coordinates, you take some points, and then this is the expected value, which is we have already seen. And our job is to find an equation or a line, right? Something like this, which is 2x plus y, which is not given to us, but we have learned it from the data, right? And machine basically, based on the every boundary that it puts and the error which is already got, it tries to come to a equation something like this, and z is basic. I mean, based on this equation, we can able to get a value for an unseen data. Right? These are the values that we have already seen, but for any other value which we get in the future, this boundary is going to, if you have enough data in the training, that this equation is going to give us a generic boundary which will suit all the data, right? So this is one slide I just want to touch upon a small sometime, and then probably we'll end it there. There are three different types of machine learning area when we talk about machine learning, which is supervised. Supervised is when you have already seen some data, right? Like sensor data, and if if the values of the sensor are so and so, you know what is the outcome, right? And you use this data. Based on that, you design an algorithm or some rules or a boundary, right? Anything, and which you apply on an unseen data, right? So that is called supervised. Supervised is where you have a training data where you have x and y values and also z values, right? And you design an algorithm using all these values, right? Unsupervised is you don't have a label for it, you just have a sensor data, right? Or for example, in a NLP, right, natural language processing, if you have a text, so Wikipedia, if you take a Wikipedia text, right, based on that, so in a unsupervised is you need to predict what is the next word, right? So if you give a machine 1 to 50 words, and you need to tell that 51 word is the next word, right? So you don't need to label this data because you already have all the data for this kind of a task, right? Or you receive a signals from um, sensors, and there are two types of signal that you receive, right? And you can cluster those the values that you receive. For clustering, you don't need any labels, right? So all of them go to a supervised. Reinforcement learning is something where you learn from your mistake. For example, if a small boy who is trying to balance a stick on his hand, right? What you do when a stick goes towards your left, you move your hand and you make it stand straight again, right? So the learning that you're doing is moving your hand towards left or right based on to which side the stick is falling, right? So reinforcement learning is same where based on the mistake and what action you basically take. So this is the basic of machine learning that we wanted to talk. I'll pause here and I'll hand it over to Maruti. Maybe some more slides on what is supervised and all of that. Yeah, over to you, Maruti.
Yeah, thank you, Manjunath, for the nice, the talk on like how AI and ML can be used in smart factories, how data that is received from sensors can be utilized to, make factories more smarter. So now I have two more colleagues, my friends, who will talk about, general applications. One is Dr. Arsha from Aerospace Engineering IIC, who is a distinguished scientist in one of the leading simulation companies. So we'll discuss more about the applications. Yeah, over to you, Harsha. Let me share the slides. Just a second, I'll share the slides. Go to Dr. Harsha. Yeah, please.
Yeah. Yeah. Hi. Hey, thank you, Maruti. So I'll be covering up on the specific applications that Abhilash had shared in his previous slides. So the main goal of having a, human robot interaction is to mimic the operations that humans do in many of these sectors, and those sectors are very commonly being seen by us, which is industry, medicine, and sometimes you also see these robots in certain key companionship roles. So have I'm gonna say certain short applications for supporting each of the examples. So let us say you have this industry robots wherein the goal is to uh, mimic certain operations what humans do, and in certain applications where it is hazardous environment, these are the areas where the industrial robots will be very useful. Robots are useful lies with certain operations or maybe certain repair techniques wherein the machine is able to read the image and it is able to replicate the necessary operations. So if I take an example of that, in an assembly line, if you have uh, a set of assemblies where parts have to be manufactured as per a design procedure, it could be found that certain fasteners or certain operations have been wrongly been made. So a human has a tendency to let go of these things because of certain human factors, but when it comes to a machine, it is very precise and it identifies certain missing parameters. So computer vision along with industry application is very much used these days. And one more key application of using this HRI technique would be medical robots. Suppose if I take an example of a brain surgery wherein the skull has to be drilled with precise speed and feed rate, there is large tendency of human to have variations in respect to his gestures. So there are technologies, wearable technologies by humans, which ensures that certain quick movements or certain jerky movements can be avoided by the machine because it has been previously calibrated to do certain operations. So this is one of the application of a medical robot, especially in the rehabilitation case. You also have a uh, robot which supports the medical condition, which is to treat autism spectrum disorder. They call it ASD. So there has been study and research which proves that humans having these disorders have tendency to connect with the machines unlike human beings. And what would happen is you have certain cognitive actions what a human being does to another human beings, like mimicking feelings, mimicking thoughts. Those can be programmed using complex mathematical models, like how Manjunath had talked about using AI ML to solve finance problems. A similar mathematical model to have an outcome of cognitive behavior can be used in autism disorder kind of situations. And these days you have smarter libraries wherein you have education robots which deals on the cloud computing concept, which Abhilash had covered upon. So you have a large repository in the cloud, and and these days you just have to maybe show a picture or have a voice command recognition to get certain information. And ChatGPT is one of such example. ChatGPT is a bot wherein it takes in your information in terms of text as well as maybe in sometimes in speech format, and then it compares its input to the available knowledge which is there in the cloud, and it makes certain rational decisions on and constraints to bring out the outcome. And the best part of the education bot or chat gpt kind of thing is it starts to reason itself and it starts to correct itself. So and this is just the beginning of having AI being used for the education sector. And also, as we all have seen in news and other places, the automatic driving or autonomous vehicle is another key sector which is being picked up very well. And it uses almost all the interactions actually, like be it the cloud computing and be it the cloud storage data, the gesture control, the computer vision. Because if I have to drive a car, I have to rely on many aspects of cognitive abilities. So these technologies would also enable us to have a safer rides and even help us. Uh, so there are many examples wherein you could use the computer vision, speech recognition, linking with the cloud data to do certain operations in a smarter factory. So these are some of the examples that I thought it would be useful for applications, and it would benefit in the coming future. So I'll just hand over the PPT to Maruti to continue on this. Thank you.
Thank you, Dr. Harsha, for the nice overview of how all these technologies can be used in smart factory. I mean, all of these technologies and how the smart factories are built and where they're really used, like how we can leverage this technology. Now, my another friend, Suhas, who is a serial entrepreneur and currently is a CEO, and he also is the co-founder of one of the startups which kind of utilizes some of these technologies, and he will give his entrepreneurial perspective of this human-robot collaboration. Over to you, Suhas.
Thank you, Dr. Maruti. Hello, everybody. I'm Swas. I have a startup which is in space technology we develop high precision components, which are antennas and solar arrays that going to go onto satellites. So we typically work with very high precision machineries at sub 10 micron levels. So reliability, error-free, and high quality products have to be generated or produced on a massive scale. So we listen to our eminent speakers talk about uh, uh, data collection using sensors, the hardware. Then we move from the hardware to the analysis of data that is coming from the hardware, where the data is analyzed and then given out. Now, as business owners, we're more concerned about analyzing the data, making sure that the components are the higher quality. Have attached to and a high quality. So having robotic having robots in or has shown that the reduction errors in high precision machined tend to move towards automating our manufacturing. So having a Six Sigma manufacturing unit gives our customers extreme confidence in our product, because anything that goes into space, especially, you cannot go up there in space and repair or refurbish. It either works or does not work in space. So we have to be extremely accurate and error free. So having these uh, having automation uh, and having robots that can replace humans in assembly, integration, and testing facilities would uh, make our business case more robust.
So we're not able to audible, sir. It's not audible, sir.
Hello, sir. Sir, your voice is not audible, sir.
Sir,
Sorry, we lost internet.
Apologies for the disruption in the internet. So, as I was talking about how smart factories can help business owners like ours, just to go into a little more detail, smart factories with HRCs can respond quickly to market demand. This is expected because the market demand, as you have observed, is very dynamic in the recent past. So, automating factories would ensure that changes changes in any market conditions can be quickly incorporated in our products and help us stay in the front seat of competition. So, in that
hello, sir. Sir, once again, there is a problem in
Yeah,
the.
hello. Sorry again. Yeah,
Yes, sir.
sorry again for the interruption. Uh,
Yeah, apologies for the network issues. So, just to conclude, as a business owner and also as someone who has been trained in the scientific way of looking at technology, uh, there is tremendous potential for collecting data using the next gen hardware and then using AI ML or leveraging AI ML models to analyze these data points and then presenting a sensible analyzed data that can be interpreted by business owners like ours to take quick, rapid, market changing decisions to keep our company in the forefront is what would make this new cutting edge technology useful for us to move forward. So, I would like to conclude with this point and over to Dr. Maruti.
Yeah, so this kind of ends our talk. I hope you all enjoyed. Yeah, in the interest of time, we'd like to end here. I think you had a lot of questions, but since we are 1 minute past the time, I mean 7:30, so I would like to end. Yeah, we could go on. This is very interesting and a broad topic, and I had still had enough speakers left. In the interest of time, I'll end here. Thank you all for listening. Over to you, Nagbhushan.
Thank you, sir. Thank you very much, sir. And even I'm very much thankful for your team members also, sir. Participants, any questions from your end? Participants, kindly ask any questions or any queries.
Yeah, hi, Nagbhushan. I don't think anyone has any questions. So should we end here? They can email.
Yes, sir. Yes, sir.
If they
Just
have any questions, yeah, they can email
yes,
to you and you can forward those
yes, sir.
questions to us. Yeah.
Yes, sir. Yes, sir. I'll take care, sir. So, dear participants, can anyone give the feedback about this session? Please kindly enable the video while giving this feedback. Okay. Participants? Okay. So, thank you, sir. Thank you once again, sir, for this informative session. So, hello, everyone. On behalf of New Horizon Management Principal, Dean, Director, HOD, and faculties, I thank the session speaker, Dr. Maruti NH, sir, and also with his team members for taking his time on transferring the knowledge on the topic human-robot collaboration in the smart factories. So it's a great learning for all of us. Thank you very much, sir. Thank you all the participants for joining the session. And even I also thank ACT ATAL for giving the opportunity for conducting this program. So thank you very much, sir.
Thank you, sir. Thank you.
Thank you very much, sir. So participants, I'm here by posting the feedback and quiz link for this session. I request all of you to kindly fill this link. So which will be enabled for 20 minutes. So in the chat box, I'm going to post the link, and even in the WhatsApp group also, I'll share that link. Okay, so dear participants, I posted that in the chat box as well as in the WhatsApp group also. Kindly fill that. So exactly at 7:45, we'll start the next session. Speaker is already in the meeting. So he's joined the group. We'll start by 7:45 p.m. Okay. Participants, will start the next session. So the next session speaker is Mr. S. Naveen Kumar. So he's a lead design engineer from Tata Elxsi, Japan. So his topic is on supply chain 4.0, digital transformation in logistics. So Hanuman sir, over to you, sir.
Good evening, everyone. Myself, Hanuman. It gives me the immense pleasure to introduce the esteemed speaker of the day, Mr. S. Naveen Kumar. He is presently working in Tata Elxsi, Japan from the last 3 years. Sir is having total 17 years of experience with 11 years of experience in Japan at Subaru, Suzuki Motors, Nissan, and Minori Solutions. 7 years of account management experience, which includes business continuation, customer relationship, and vendor management. Sir is having a wide range of experience in design and development of bumper design for both gasoline and EV vehicles, experience in pursued quality projects for bumper, experience in CE analysis field for durability, NVH, crash, and thermal simulations for various vehicle subsystems. Sir has got various awards such as Best Buddy Award for Quarter 2 2024 at Tata Elxsi, Rising Star Award for the year 23-24 at Tata Elxsi, the Numero Uno Team Award for the year 14-15, Feather in My Cap, and PES Signing Award by Wipro for outstanding contribution in the team in the year 2012, Bingo Award by Geometric Limited for customer satisfaction in the year 2011, Best Team Player Award by Wipro in the year 2010. Sir has published one paper on redesign of disc brake assembly with lighter material. Now I welcome S. Naveen Kumar on behalf of the Department of Mechanical Engineering, New Horizon College of Engineering, Bangalore, to deliver the talk on Supply Chain 4.0, Digital Transformation in Logistics. Over to you, sir.
Yeah, thank you so much for the kind introduction, sir.
Okay, thank you, sir.
So, are you able to see me?
Yes.
Yeah, okay. Thank you so much. So let me share my screen. So very good evening to one and all. Today, let's discuss about the topic Supply Chain 4.0 Digital Transformation in Logistics. So we'll be talking about the current supply chain technologies, the emerging supply chain technologies, and how to transform your supply chain. Okay. So how will the business look like in the future? So how you will execute the business, how the supply chain will look like in the future, how you will monitor all the activities. See, as we know, every business is different, but there are two main aspects which is common in every business. It's the supply chain and the technology. So as we all know, the technology around us is advancing very fast. So we need leaders who can understand this technology and see where we can adapt that technology in the supply chain. So many of the speakers have already spoke about this, the industrial revolution. I'll give a brief knowledge on this. So around 1800 AD, we faced the first industrial revolution during introduction of the steam engines and the railway lines. In 1900 AD, due to the introduction of electricity and the assembly lines, we saw second industrial revolution. And around 1960 AD, where the semiconductor was introduced, the computer came into picture. So we saw third industrial revolution. In the year 2017, Klaus, who is the founder of World Economic Forum, he wrote a book called Industrial 4.0. See, this showed us the way how to look at the technology. Now we are in the fourth industrial revolution, which is inspired by robotics and AI technology. So there are major technologies which has come together and it has transformed the way we look at our society. Some of the major technologies are the 5G communications, the sensors, IoT, Internet of Things, the AI, which is called artificial intelligence, gene sequencing, and the nanotechnology. So when we speak about supply chain management, it's not only about movement of the product within the supply chain. So it's all about what the customer values and what the customer is ready to pay for. So it also includes the services and sometimes the digital products as well. Utilization of technology in supply chain management, it influences the way the material flows, the information flows, and the money flows within the supply chain. Yeah. So in order to prepare for the supply chain 4.0, the Singapore Economic Development Board, they have formed a strategy or the tool called Smart Industry Readiness Index. So they have defined 4 steps. One is learning of the key concepts and building a common language for alignment. So this is the fundamental step. If we don't understand the key concepts and all the engineers or the participants in the team don't have a common language of alignment, we will fail for adoption of supply chain 4.0. The second step will be to evaluate the state of existing facilities and the company's readiness for Industrial 4.0. So the third will be architect comprehensive transformation strategy and implementation of the roadmap. And the fourth will be delivering impact and sustainable transformation initiatives. So we have to adapt and sustain the transformation in order to become success in digital transformation. Okay, so let's talk about information value chain. Talking about data. See, nowadays we collect lots and lots of data. For example, phone number is a data, name is a data. See, if we have phone numbers and the name, it really don't help us. So once we have a relationship between those two, we will understand that if we call this number, this particular person will answer us. So the data, when we organize it properly and define a relationship, it will become information. So we can use this information for judgment. Once we have the information, we organize the data more properly by sorting and filtering the data. We can get some sort of patterns. Using the patterns, we will have the knowledge of the whole data. With this knowledge, we can go for institution and the judgment, which will give us the wisdom. So this data transform to information, transform to knowledge, which transform to wisdom is called as information value chain. Now let's map the machines and the people against this information value chain. So we know that the machines are very quick in processing the data. So at the data stage, they're very quick. We can utilize all the computers for doing this task. But When we apply relationship and we want to take decision, so machines are not reliable. So while going towards the wisdom, the reliability of machine comes down. Whereas the people on the other hand are very good in judgment. They're intellectual. So the people will have good decision process, but coming to data handling, they may not remember all the phone numbers. Okay, so there is always a trade-off between the machine and the people. We call it as human-machine interface. When we take supply chain management, we have a lot of processes like creating production schedule, placing orders with suppliers, booking transportation, etc. See, most of this involves collecting the data and processing the data. So we can directly hand it over to machines because they are smarter at that process. So nowadays, we see that the machines are becoming smarter and smarter. So the previous curve, it has gone towards right and little upper, if you see here. So the human-machine interface also we can see the shift, the trade-off between the machine and the humans, there is a shift. So this particular gray region where the machine, the human-machine interface is shifting is the region where the automation can happen. This is what digital transformation of supply chain is all about. So going further. So if you have any queries, you can stop me at any point of time. Thank you. Okay. So if you see supply chain is mostly made up of the processes. So the processes, most of the companies uses a tool called as supply chain operation reference model in order to organize these processes so that we can automate the process by replacing the people with machines or the software. See, all the processes can be categorized into 6 different categories. One is plan-related process, source-related process, make-related process, deliver-related process, return-related process, and enable-related process. So as we know that each and every process will have its own tasks. To identify the tasks in the process, it's called as process mapping. So if we have simple process, we can just list down all the activities, and that list of activities can be used as standard operating procedures or standard work in terms of lean. But when the process is very complex, we will use flowchart to represent how the process, how the tasks can be identified. So if we take example of a software, so we will define the tasks which the software performs using the activity diagram. So we all know that this particular oval shape represents the begin of the flowchart. Oval represents the end of the flowchart. The rectangle is where the process or the tasks happen. And the diamond shape will represent the decision taking step. So concerning software, this activity diagram is modeled using special language called as unified modeling language technique. So sometimes we might have to draw the flow diagram to involve interdepartmental or cross-functional activities. So we use swim lane diagram to represent those sort of process mapping. So here, for example, marketing division, the management division, and the web design team, so is marked here The horizontal and vertical activities represents who has to do what activity at what stage. So some of the companies who follow the lean or the agile process, they usually process the tasks using value stream mapping. So value stream mapping is a special type of mapping where you will have the volume of materials flowing through the process and the time taken for each task. So going further, as I said, each and every process can be automated. For this, we have to identify the tasks. The tasks can be physical task or the information task. The physical task can be automated by replacing the people who is performing the particular task by using machinery or the robots. So these robots can be stationary robots or the mobile robots, or sometimes we can use cobots, which work along with the human interface. And the information tasks such as uh, the data entry, the data collection, or the data extraction can be automated using artificial intelligence, the AI. So one of the best example is robotic process automation, where the software will understand how to collect the data and how to process the data just by looking how the human works. So this is about the automation of the tasks within the process. So in supply chain, we come across lots and lots of data. And most of the data comes from the transactions within the system, such as the enterprise resource planning system, the warehouse management system, or the transportation management system. Nowadays, we are also using Internet of Things or the IoT, such as the automated devices, cameras, thermometers, the location trackers. So even these will collect lots and lots of data. So nowadays, this transaction system have also improved, and IoT we are using a lot. So there is literally lots of data we are collecting the supply chain. So these data will fuel to something called as big data. So the IoT and big data are the two trends which are closely trending nowadays. So if we consider big data, so as I said, it consists of lots and lots of data. So the first question will be where and how do we store the data? If we have small amount of data, we store it in a single server. If we have large data, we will go for group servers or the data warehouse, which is centered in the data centers or the server farms. See, in order to safeguard the data, we need to be aware of the redundant hardware, the physical security or the cyber security attacks. So we need to take backup of the data. So this data can be classified as the structured data, unstructured data, and metadata. Structured data example is like simple spreadsheet where we have the data organized in a particular fashion. So unstructured data can be something like the photos, the videos, or the social media posts, etc. And coming to metadata, for example, if we take a photo using our camera or the mobile, we save that picture by giving it a name and the date. So that name and date is what is called as metadata, which will refer to the particular unstructured or the structured data. So these datas, along with the right infrastructure, if we use it, we can get into the valuable insights, so which will help us in the growth of supply chain. So the organized data, we can use it for better production plans, inventory forecast, the payment for products and services, and also how to charge the customers. So we can analyze all this using the structured data. By using unstructured data, such as social media post or the video audio files, so we'll understand what are all the problems going around our product. So who is commenting on what are the problems, so how to fix it, we can decide on it. And if suppose there is a complaint that there is delay in delivery of a particular product, so we can very well understand that and improve our inventory and the stocks. So sometimes by seeing the news, we can understand the traffic through the ports and the highways. So these are all related to unstructured data. Sorry. Yeah. So let's move on. So as I said, supply chain mostly consists of collecting data. So once we have the data, clean it, organize it in order to get the proper insight using the data, we need to undergo or do advanced analytics. We have 5 different types of advanced analytics today. These are descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics, and advanced analytics. So descriptive analytics, if we talk about, it involves mainly sorting and filtering the existing data. For example, if we take the sales record or the production volumes, inventory volumes, if we analyze these historical statistical data, we can understand what exactly has happened. Okay, so this is what relates to descriptive analytics. So when we come to diagnostic analytics, it will compare what actually happened and what you expected to happen. For example, the sales forecast can be compared with the result. So this will help us to identify why did it happen and in fact why it did not happen. So this is diagnostic analytics. Coming to predictive analysis, so as the name itself tells, we will predict the future using the past, which means in technical terms, using the historical statistical data, we can do the future predictions or the future probabilities. So this is about the predictive analysis. Coming to prescriptive analysis, this is the stage where we use AI. So here, the AI will help us to analyze the historical data with the real-time inputs, and it will give us some suggestions. So this is what you have to follow. The main drawback here is as humans, we don't understand why the AI is giving such a suggestion. So we have to blindly follow the suggestion given by AI. And coming to next type of analytics, which is advanced analytics. So this is where this is still in research stage. So where the computers will be able to take its own decisions and it will take the actions as well. So this is all about the advanced analytics. So let's continue to the interesting topic, artificial intelligence and machine learning. See, day in and day out, we interact with intelligent computers all the time. For example, if we take photo using a mobile camera, so it has got an application which can tell, which can sort out the people. So you might have seen in iPhones, and most of the bank uses applications to find out the fraud detection. And sometimes if you go for online shopping, so there will be a pop-up box which allows you to discuss with the chat box. So it will give us, it will basically answer for all our basic questions, the basic needs. Human, yes, we are intelligent to analyze the information, make decision, and take actions. I'm sorry, just a moment. I'm sorry, guys. Like I'm using heater here. It's too cold, so it's becoming dry. Yeah. So we're talking about intelligence. Humans, yes, we can analyze any sort of information. We can make decision and take action. But for a computer or a machine, it cannot analyze the information, make decision, or take action until and unless we give some instructions or the program to it and tell them what exactly to be done. So in simple AI, artificial intelligence, it will look for patterns and exceptions. For example, if suppose if we log in into our Google account, the mail ID from different state or different country, so initially it will not allow us to access. It will generate a passcode and it will verify whether the right person is accessing the mail or not. So it basically looks the pattern. We usually might have worked out of India and suppose if we go out of country, so it's away from the pattern or away from the expectation. So this is sort of simple AI, what I introduced. Coming to advanced AI, the computer learns how to solve the problem on their own. So this is exactly the machine learning. This is the difference between AI and ML. ML is the advanced version of artificial intelligence. So in machine learning, how do we do that? So machine learning, initially we give a set of inputs or set of instructions, the gray line, or set of rules, I can say in better terms, set of rules, the gray lines. So certain rules, we can keep it flexible so that the machine can itself decide. For example, the blue line. So instead of going in this particular rule, it can deviate from the rule. And we can give a lot of sample data to the program and give the feedback as well. So instead of doing this, it will learn from the sample input and the feedback, and it will redirect its decision from blue to green. So which means the machine, it cannot do 100% perfect at the first time itself. During the process of feedback and the input data, it will learn itself and slowly, step by step, it will go on to achieve the 100%. So we can use this machine learning for scheduling production runs, order inventory, track shipments, etc. And we also use this machine learning in day-to-day life. For example, the voice recognition, what we use in the Siri app, and the facial recognition also. So these things are basically the machine learning programs. Yeah. So any computer, for the matter, it's used for two purposes. One is the storage and to process the data. So we store the data in order to retrieve the data when and where it's required. So for this particular thing, for our supply chain activities, we cannot depend on single computer because of its limitation in the storage and the process. So we have to consider connectivity of computers. So combine the computers. So we'll talk about the architectures. We have different architectures which combines the computer. One is centralized computer. So let's talk about the client computer first. Let's understand the client computer, then we'll go on to the centralized architecture. So client computer is nothing but a simple mobile or an iPad or a computer where the user will interact with the system. So this has got limited storage and limited processing capability, since it has to be portable and cheap. Okay. So to connect the different clients, in order to improve the storage and the process, we usually will connect to the server. This server will have higher storage capacity and higher processing capacity. This sort of architecture is called as centralized architecture. So there is one disadvantage in the centralized architecture. That is, if the server is hacked, the entire data in the network will be vanished. And suppose we have this server in our office, the distribution center, or if it is part of our LAN, we call it as on-prem servers. If it is placed at a remote location and is controlled by a host, we call it as cloud server. So we'll connect to cloud servers using internet, whereas on-prem server using LAN. So going further, so we spoke about the centralized architecture. Now we'll be speaking about the distributed architecture. So nowadays, the computer technology is getting advanced so that the client itself can be used for processing and storing more amount of data. So here, if you see, the client is very small. Here, if you see, it has become big. So this is sort of distributed architecture. Advantages, even if the server is hacked or any data is problem, we can still work on the client. But the problem with distributed architecture is we have to manage the client as well as the server, which is a little bit hectic task. So nowadays, company started using hybrid architecture or the edge computing technology, where the client server usually interacts with the edge server. It can be on-prem server or the cloud server. This edge server will form a gateway to the bigger central server, which is kept at the host site. For example, the vehicles, the logistic vehicles or the plane can interact with edge server. From here, the data can be transferred to the central server. Yes. So this is all about the current supply chain technologies. Let's move on to the emerging supply chain technologies. So am I too fast or time is okay? Yeah. So do you have any questions until now? So Gopal sir, can we continue?
Yes, sir, you can continue, sir.
Okay, thank you. So let's
Yes, sir.
move on.
Yes, sir.
Yes, sir. Thank you so much. Okay.
Yes, sir. Continue, sir.
Okay. So let's move on to emerging supply chain technologies. So first, let's see about autonomous vehicle. See, as we are aware, this autonomous vehicle is just a mobile robot that travels without human giving the real-time instructions. These robots can be programmed to follow a specific route, or it can be intelligent enough to choose its own route. So for example, the drones, we can use the drone technology to deliver a parcel. This drones need not be always the aerial one. It can be, it can also be one which goes into the sea or the river, water path drones, or even sometimes the land drones can be used. This autonomous vehicle we also use in the production plants where a small autonomous robot carries the pallets back and forth in the production area. And yeah, this one from past 1 year, we can see this in Japan food restaurants. This is a robot which delivers the food to the table from the kitchen. As well as we can, after eating our food, we can place back our trays. So this will carry all the utensils back to the kitchen. So in such a way, the autonomous vehicles helps us in our day-to-day life as well as in the supply chain. This autonomous vehicles we mainly use for inspecting facilities in the remote area where the environment is very dangerous. And during natural calamities, in order to give the medical supplies or the food, we can use these autonomous vehicles. So for the digital transformation, we need to think what sort of vehicles we need to use for transporting the products as well as the people in our supply chain. Sorry. So yeah, coming to supply chain, usually supply chain is made up of the people, the process, and the technology. The way the people, the process, and the technology interact with each other, it's very hard to predict. So nowadays we use digital model to help us analyze the complex supply chain by virtual method. Okay. So the digital model basically has to tell two things. One, something we already know, because if you program or make a digital model, it has to first tell us what we know to understand that the digital model is working perfect. And second thing is it should tell something we don't know, because this is where the real use of digital model lies, right? Prediction of something what we don't know. For example, the engine of an automotive vehicle. We can use a digital twin of the engine so that we can continuously monitor the engine in the digital format. So if there is any failure happening in the engine, so immediately we can replace it with new engine. Or in other terms, if we are well aware, if we are priorly capable enough of predicting the failure, so we can always avoid the disaster. So in such a way, the digital twins or the digital model is helping us. So we have three types of digital model. One is digital twin, the simulation, and the optimization. So as I gave the example of engine, it comes under digital twin. So this digital twin is a file or the program that describes important physical attributes of the product or the process. So with this physical attributes, the digital twins help us to understand what is happening now. Coming to simulation, this will help us to understand how the supply chain will behave for a given set of conditions. In simple terms, it will help us to predict the future by analyzing or simulating something. Coming to optimization, see, we will always have something in mind. This should be our target. So the model, we have to fine tune or optimize it in order to achieve the proper output, what we are expecting. So that is called as optimization. This we can change the model in order to get the desired output. This is the difference between digital twin, the simulation, and the optimization. All three are the digital model. So in digital model, especially in optimization, we have lots and lots of methodologies like discrete event simulation modeling, Markov chain models, Monte Carlo simulation, and system dynamics model. So we are already aware of these things. I will not talk on first three, but if you want to go for digital transformation of supply chain, so this is very important. This is where you have to start. This system dynamics model helps us to understand the interaction which is happening in the supply chain. So how the inventory moves in the supply chain. What will happen if there is any change in the supplier demand at each and every stage. So this is about system dynamics model. So this is where we have to start. So the modeling provides clarity about what happened in the past, what's happening today, and what is likely to happen in the future. So let's move on to additive manufacturing in supply chain. Yes. So today, most of the manufacturing process involves subtractive approach. For example, cutting off a shape, the drilling of hole, or grinding away the material. So these are all subtractive approach. It creates a lot of waste during the process. So nowadays, people have started to use additive manufacturing, so which usually involves adding the material where exactly it's required. So in order to, by doing so, it will avoid the wastage of material. So the important aspects to decide whether to go for additive manufacturing or not is the cost, the size, the shape of the object. So these three factors will compel us to go for will give us the direction whether to go for additive manufacturing and what type of additive manufacturing process we have to adapt. So speaking about additive manufacturing, this becomes very interesting if we see these factors. Designing of complex shape. So we can manufacture a part which is lightweight but with more strength and with complex shape. So that is the combination we can achieve using the additive manufacturing. And we can go like mass customization is also one important point. It's not mass production, but mass customization. So depending on the customer's requirement, so we can change the design then and there itself. So we can create the product on demand. So by this, we can eliminate the inventory and transportation. So we can, in fact, set up a plant in different part of the city or different country altogether. So we can deliver to the customer then and there on need basis. So we can also use this additive manufacturing for rapid prototyping to check the fit and finish or the fit and function of any product. Before manufacturing a car or, for example, a bumper, so we usually go for prototype to understand whether it's functioning properly, whether the fit and finish is proper, whether the gap requirement is proper. So all this we can understand with rapid prototype. Yes, of course, by using additive manufacturing, costs will be too high. But if we consider as a supply chain completely, this high cost can be controlled by less inventory and less transportation cost. It often shortens our lead time, so it's advantageous. So what we make when we make, and where we make actually decides the digital transformation in the supply chain. So communication is one of the foundation in supply chain. So we'll see 5 communication technologies which we are using in the current world. So one is fiber optics. So nowadays the fiber optic connection, we get it in home, office, factory setup. So this will literally connect all the stationary computers throughout the world. And second thing is short range wireless technology. One good example is radio frequency identification. So this radio frequency identification number, we can place it on the pallets or the packages which moves through the supply chain. And we can track the movement of these pallets and the packages by using radio frequency identification number. So coming to a third type of communication technology, it's a wireless mesh network. So this is sort of Wi-Fi technology where we use in a small area, such as LAN, localized area network. So most of the hotels or restaurants or the industry, they use this wireless mesh network in order to give internet supply to its users. So coming to wireless cellular technology, the 5G technology. So nowadays, the 5G technology has advanced so much that 10 times more devices and 100 times more data can be shared by using this 5G technology. And yeah, recently companies are placing their own satellites in the orbits so that they will have communication with various parts of the world. Okay, we'll move on to augmented reality in the supply chain. The distance and time are the fundamental properties of the universe. By using AR and VR, we can solve some of the problems related to this distance and time in our supply chain. So augmented reality, it's basically addition of digital information to the world around us. For example, if we have a goggles, if we see a product, if it can tell um, what is the inventory level, so when it has to be shipped, where it has to be shipped, at what time it has to be shipped. So that exactly is called augmented reality. For example, if you see here, this tab is projected onto this particular inventory. It will tell us how much volume is there, so when it has to be distributed, and all these information. This is use case of augmented reality, where it adds digital information to the world around us. Coming to virtual reality, it actually immerses us in a completely digital world. It uses the 3D images, like we use these goggles. It usually has got 3D images, and it will manipulate our mind, confuse our mind in such a way that we can feel as if we are in a different location or the different world altogether. So we can use this virtual reality mostly in simulation purpose. Um, we can actually prepare the complete assembly line and walk through it using this virtual reality. We can also use this for training our employees using virtual reality. So the AR, VR can change customers' expectation and create new opportunities to transform our supply chain. Okay. So in today's business world, the major problem what we are facing is storing of the information securely, exchanging information with our customers and suppliers. So usually in supply chain, we will have lots and lots of data, as I already told you. Like it can be the production data, the inventory data, the transportation data, even the customer data, even the supplier's data. So it should be properly secured and properly exchanged. So the information flow has to happen in a proper path. For example, if a company places an order, so buyer will place a purchase order, they will have the purchase order number or the routing number or the transportation number. So this will be saved in the buyer system, buyer organization system. So on the other hand, the seller will generate the sales order, which will have tracking number, the information when it has to be dispatched. So these informations will be stored in seller's place system. So basically, for the same product, the buyer is saving the information in buyer system and seller is saving the information in seller system. So basically, the effort is being duplicated for the same product. So, and also this information has to be passed down to the buyer. This information has to be passed down to the seller. So it's a sort of front and back information passing is happening. So this can be avoided by using blockchain. Blockchain is basically a database where a lot of stakeholders can see the data or access the information. By using the blockchain, the buyer can save the information here and seller can save the information here. This will reduce the duplication of efforts. And this blockchain can be duplicated at buyer end, can be duplicated at seller end, so that if there is any attack on this database, so we will have a backup. And the same blockchain, we can give access to various companies so that all the companies can see how the product is flowing through the supply chain. So this is how the blockchain will look like. And sometimes this blockchain will be open to the outside people. This is mainly for auditing or compliance purpose. So we can also limit the access to these people. Only the necessary information can be flown out. So all this sort of thing we can do in blockchain. So this like since it's handled as a ledger, it sometimes is also called as distributed ledger technology. So some of the advantages of blockchain is we can do smart contract. For example, if the product reaches from the seller to the buyer, automatically the payment generation will happen from the buyer, it will go to the seller. This sort of smart contract can be done using the blockchains. And we can use this blockchain to store pictures, music, even the digital twins. It's called as non-fungible tokens. We can also track cryptocurrencies. Sorry. Yeah. Due to its simplicity of storing, sharing, and securing the data with blockchain, it plays an important role in the digital transformation of supply chain. We'll go further. Yes. So most of the computers, what we are using today, it processes the information as a series of binary digits, ones and zeros. So the basic unit of information in binary terms is called as bit, where 1 represents on and 0 represents off. So this can be used for solving simple problems by using the computer. If the problems are very complex and That too, if it involves lot of scenario and we have to evaluate all the scenario at a time, we cannot depend on this binary format, because binary format can solve one scenario at a time. For example, if scenario A is solved, it will give the result. Then it will move on to scenario B. It will take the result. It will move on to scenario C. It will take the result, and it will go to scenario D. Scenario to go for complex problems. Nowadays we are talking about the quantum computing, the basic unit of which is called qubit. In qubit, it can be either one. It's not either one or zero. It can be one or zero at a time. So this is benefit of qubit. In binary bit, it can be either 1 or 0. So qubit, it can be 1 and 0 at the same time. So this is where it becomes interesting to solve complex problems with a lot of uncertainties involved and with a lot of scenarios at the same time. So this quantum computing we can use in networking, routing, and forecasting purposes. So how do we secure the data? We usually secure the data by encrypting some sort of mathematical algorithms. If we have to make this algorithm more complex, okay, so we need to have computer with more analyzing capability or with complex problem solving capability. So this is where quantum computing comes into picture. It plays a crucial role for planning, manufacturing, inventory, and transportation. So going further, cybersecurity, like recently in 2021, one of the company was attacked, and almost 6 days they had like the hackers had blocked the pipeline for gasoline, the diesel, and the jet fuels. So a lot of transportation was disrupted. This gives us a very good lesson why cybersecurity is so important in our digital transformation. So there are a lot of threats, like data can be stolen. It can be the design data. It can be the personal information of the employees, the customers, or the suppliers. So these data can be used for threatening purpose or making duplicates. And sometimes there is threat of losing the data or losing access to the data. And sometimes there are attacks. So these are the threats concerning to cybersecurity. So let's see some of the attacks. Designed in vulnerability. See, for any software company, so it's not guaranteed that the first software release will be 100% matured. There will be program errors. So these attackers, the cyber attackers or the hackers, they will pitch in, see these vulnerabilities, the errors in the software. So as a protection point, we need to keep all our softwares up to date. So these software people, what they do is, in order to mature it to 100%, they will release patches, patch by patch. So we have to keep all our softwares up to date. Brought in vulnerabilities are something like the virus, malware, or the configuration changes which attack our system. So we have to use antivirus softwares, educate our engineers properly, and securely security settings we have to be adapting properly. So and there is direct attacks. These direct attacks is something like they will crack open your password, or sometimes uh, take your system itself. It can be physically taken out of your system. So we need to have physical security procedures, complex passwords, biometric tools, etc., to prevent this direct attack. So customer and supplier, they depend on us. So it will be our risk as a supply chain facilitator to give protection to all the data. Yeah, coming to combination of the technologies in supply chain solution. See, one most question like ask this, where is my stuff? Where is the product? A lot of companies are improving the track and trace process for their inbound and outbound. Inbound of material, outbound of the product. So it's our responsibility to choose right set of technologies and to integrate them in order to get a solution. So this is all about the emerging technologies. Now let's talk about how to transform our supply chain. See, the first and foremost step is to identify the new business model. So we have 15 minutes time. I'll make it quick. Okay, so the digital technology usually transforms what the customer values and what they're willing to pay for us. So we have 5 different types of new business models which are applicable for digital transformation of supply chain. The first one is automation. So as I already informed, like in the supply chain, the activities which is being performed by the person can be automated by using machines or the software. So this is about the automation. Coming to digital marketing, the Uber, Airbnb. So these are all the digital marketing platforms where they connect the customers with the suppliers, and for every transaction, they will take a small fee. Or sometimes it's only the membership fee what they charge. This is all about digital marketing. And the third type of business model, what we have to focus is digitalization. The best example is the CD, which is used to see a movie or hear the song. We can completely eliminate the physical product and go for digitalization, like streaming music, which is available in YouTube or some other applications. So we can totally avoid the physical part of it. And coming to servitization. So this is where our thinking will have a total shift. Instead of selling a product, so we have to shift ourselves to sell it as a service. So how does it help the customer? Like customer, instead of buying and storing the product, he can simply rent it, use it, and give it back. So that is advantage from customer point of view. From seller point of view, what is the advantage? The seller, he need not have a complex sales force, instead of which he will get consistent monetary through the subscribers. So this is called servitization, a shift from product selling to service selling. And there is one more important business model, which is new platform. So we have to think about completely new platform which was never existing. The best example is our smartphone. So it changed the way the technology is handled. So digital transformation, it may create small or huge impact, but it always shows the path for new business model. So with talk about business model, we'll continue with the business cases in the digital transformation. See, the digital transformation will not happen in a single project. So we need to plan for several projects for digital transformation to happen for our supply chain. We have to consider 3 main things. What are the benefits? What are the costs involved? What are the risks involved? First, let's see the tangible part. That's the financial part. So we have to decide whether we will be getting higher revenues. The profit margins are high or not. Or on the other hand, is the cost low? Are we lowering the cost? Or are we avoiding any cost, something like penalties paid to the government, something like that, cost avoidance. So these are all the tangible benefits. Coming to the cost part, it may include one-time investment such as hardware or the software, or sometimes non-recurring engineering costs such as training, consultation, etc. So once the tangible part is understood, we have to build a financial case. We have to show that the benefits are more when compared to the cost. So not only tangible factors, we need to consider intangible factors also in order to go for digital transformation. Something like, is our brand getting improved, or are we opening to a new market, or at least are we opening to a new digital technology? So these are all the intangible factors we have to consider for the business case of digital transformation. And sometimes we have to think about safety. So is the process more safer? Then definitely we can take that as a business case. Or in terms of environmental, social, and governance, also we can take it as a business case. And we need to also think about the risks. So going further, once the business model is defined, the business case is defined, now it's our responsibility to assemble a team. So see, in order to be successful in digital transformation of supply chain, we need to organize a proper team. This team should have the person with technology expertise. At least they should be ready to learn the technology. It should have subject matter expertise, and the people who can interconnect different digital technologies. This is part one. And the second part is people who understand the current supply chain and they have business thinking mindset. So that will be part two. And the part three will be stakeholder management people like the sales force or the procurement team, etc. So with this team, we should also think about how the team is structured, what is the relationship between the engineers or the people in the involved in the supply chain. So how to maintain the communication, whether it's a full-time work or if they are working in some other team and they are being pulled only for certain time, like 1 or 2 hours daily. So all these factors has to be properly defined in order to achieve a proper digital transformation. So once the business case is defined and the team is ready, okay, so where to position our digital transformation project is at most important. For this, the leader should have the visibility of the project. This is most important, visibility. Like digital transformation project will always have a lot of attention. It may be helpful sometimes or it may be problem also. So there are the main three reasons why we should always keep a low profile for a project is if we see high risk of failure, even a small mistake in the project, all the stakeholders will see us negatively. So it's better to keep a low profile if we see a high risk of failure. It will in fact indirectly impact our team members also. So if our project consists of intellectual properties such as any patent work or any trade secrets, so it's always better to have low profile for the project. And if suppose the team has got any opposition, uh, like people, they don't want change in the supply chain. So if we have opposers or the detractors, it's always better to have a low profile project. So three reasons why we need to have high profile project. With lot of visibility, there is always a lot of motivation in the engineers or the team members. So they will give better outputs. So it all depends on the visibility of the project. And if we have high visibility, we'll always have access to high budget. So high resources, whatever we ask, we will get it for the particular project. And since we are involving all the stakeholders, it will help us in the change management. Like it won't surprise the stakeholders at the end. They will be prepared. They'll be visioned. This is how the change will look like. So this is how you position your digital transformation project. Yes, every project is different and the circumstances can change over time. Yes, so you need to decide whether to keep low profile or high profile, or to change from low profile to high profile, or change from high profile to low profile, depending on the circumstances. So once you define the position of the project, then your leadership skills comes into picture. So leadership is something about doing the right things, whereas the management is about doing the things right. Two different terms. The project leaders should have these 6 responsibilities to direct us. So where D represents define. He has to define the project or any problem or any opportunity. So the leader has to define the opportunity. He has to investigate the various steps or various alternatives and leaders. So he has to resolve and chalk out a plan. The program management. He has to do the program management. He has to execute the planned activities so that we will be directed towards digital transformation of supply chain. So change is inevitable. Like the end result, what we want in supply chain is the change. That is the digital transformation. So, and as a last step, you should observe whether the transition is sustainable or it's falling apart. So these are the 6 responsibilities as a leader for any project, for that matter. So we are almost at end of the presentation. How do we measure the digital transformation's impact on sustainability? So nowadays we talk about the environmental issues, the social issues, or the governance issues. Like this can be addressed or talked about by using this triple bottom line: the people, the planet, and the profit. People involves the team members, the customers, the suppliers, or the region where we do our business. So everything is people. So when we speak about people, it's usually related to social justice, whether race equality is maintained or gender equality is maintained, child labor is abolished. So all those things comes under the people impact on sustainability. Coming to planet impact on sustainability, so we have to wisely choose the material what we use in the supply chain or the process, like whether we can use renewable resources in our supply chain. So the packaging, in fact, how we package the product, what material we use for the product, and in user terms, so what will happen to the product once the customer purchases it, uses it? What will happen to the product, whether it can be recycled or reused? So all these factors will come under the planet part, the impact of sustainability. And last but not the least, so every company will see for the profit. So if there is no profit, they will not go for digital transformation. So this is all I have for today. Thank you so much for your valuable time.
Thank you very much, sir. Naveen, sir.
Thank you. Thank you, Gopal sir.
Thank you, sir. Participants, any questions from your end? Any queries, any questions you can ask to Naveen, sir? Participants?
So I'm really sorry for speeding up the process. Like,
No,
so
sir. No, sir.
difficult
It's okay,
issue.
sir. It's okay, sir. No
Yeah.
problem, sir.
Thank
It was a
you.
very nice session, sir. Very, very
Thank you so
elaborative kind of session. It was very nice, sir.
Thank you.
Yes, sir. Participants, if any questions, please
If you
ask.
have any queries, you can always mail me, or you can share your questions to Gopal sir or Hemant sir.
Yes, sir. I will collect it and convey to you, sir.
Sure, sir. Sir, Vijay Rai, sir, can you give this feedback about the session?
Yeah, Kallesh, sir. Can you give the feedback, sir, about the session? Kindly enable the video, sir.
Sir, Paul, sir, can you give the feedback about the session, sir, if you don't mind?
Sir, good evening, sir.
Good evening, sir. Very good evening.
Sir, this is Dr. Arun Manohar from Gandhi Institute for Technology, Bhubaneswar, sir. So I would like to share my feedback. So regarding the session, sir,
Sir,
first of all,
kindly enable your video, sir. Please, sir.
yes, sir, yes, sir. Yes, sir, yes, sir. I'm doing that. I'm doing that. Sir,
Thank you,
first of
sir.
all, first of all, thank you so much for your patience explanation, sir. I enjoyed all of your sections and all. It was very informative. So thank you so much. And I personally, I was having so much of doubts on this additive manufacturing and the supply chain management, sustainability goals, and all these things. So I think, after this session, I got a clear idea on, and some of my doubts have been clarified. Thank you so much for the session, sir. And sir, I have one more doubt actually. While installing this software and all, we do give some control to the person. Do you think that it is safe for giving the control of a system to the persons on the other side? Is there any scope for that they try to copy our data or get the data, sir?
I'm sorry, sir. Like, your voice was not audible. It was
Okay.
breaking.
Uh, sir, is it okay now?
Yes, sir. It's okay, sir.
Sir, at times while installing the software and all, when we get stuck up with the design patterns or the process and all, we take the help from help from the vendors and all. They ask
Okay.
for the control of our system and all. So at
Okay.
that time, while sharing the screen and all, we give the control, remote control of our system to the other person. Do you think
Okay.
that that will have any effect on the security of the data that we have in our systems?
Yes, sir. Like, it depends, sir. Like, how trustworthy is the vendor?
Okay.
So first and foremost thing is, while choosing a vendor, we should select in proper way that is trustworthy. And second thing is, if you feel insecure, you need to give him the limited access to do the activities what exactly is required.
Okay.
So in
So
that way, we
you
can
say
solve
that
the problem.
uh,
Yes.
okay. You're saying that there is there'll be a scope for the vendor to copy the data if the remote access is given. From the cyber security point of view, so depending upon so there is a scope for the person to get the data or get the control of a system
Yes, sir.
in terms of the security, right, sir?
Certainly, yes.
Oh,
Certainly, yes.
okay. Thank you so much, sir. Thank you so much.
So in the
for
world
the
today,
session.
we
Thank you so
cannot,
much.
yes, sir, to add for the point, in the world today, we cannot perform all the tasks by ourselves. So we have to depend on other person.
Yeah, yeah,
It's a collaboration
yeah,
game.
yeah.
So to certain extent, we
Yes,
have
sir.
to
Yes,
trust
sir.
the people.
Okay, sir. Thank you, sir. Thank you so
Thank
much
you.
for the session. I enjoyed a lot. Thank you so much.
Thank you so much.
Anybody wants to give the feedback? Okay. Okay, sir. We'll wind up the session. Thank you,
Okay,
sir.
sir.
Thank you for the informative session, sir.
Thank you so much, sir.
Yeah. Hello, everyone.
To
So,
add on,
behalf
this
of,
information is collected information. So
yes, sir.
yeah,
Yes, sir.
thank
Yes,
you.
sir. Thank you very much, sir. On
Thank you.
behalf of New Horizon Management, Principal, Dean, Director, HOD, and faculties, I thank the session speaker, Mr. S. Naveen Kumar, sir, for taking his time on transferring the knowledge on the topic Supply Chain 4.0 Digital Transformation in Logistics. So it's a great learning for all of us. Thank you very much, sir. Thank you all participants for joining the session. So I also thank ACT ATAL for giving us the opportunity for conducting this program. So I'm hereby posting the feedback and quiz link in the WhatsApp group. Request all of you to kindly fill this link. Okay, so which will be enabled up to 20 minutes. Thank you, sir. Thank you, one and all.
Thank you, one and all.
Thank you, sir.
Thank you, sir. Thank you so much, sir.
Yeah, just I post this feedback as well as quiz link in the WhatsApp group. Participants kindly fill it. Thank you.